All right, so we're gonna get going on chapter 6. So I'm gonna share my screen and we'll get the ball rolling here. Okay, so we see my open math. And we're gonna look at some chapter 6 homework assignment. Estelle, you can see the calculator and my open math, right?
Yes, I can.
Okay, thanks. All right, so normal distribution is your basic L or bell-shaped curve, and there's some things to realize they're common for normal distributions. So you have this is going to be the mean here in the middle, so mu. And then you got a mu plus sigma, mu minus sigma, right? That's the mean plus the standard deviation. Then you got mean plus 2 standard deviations, mean minus 2 standard deviations, and 68% of the data happens within 1 standard deviation of the mean. That's like it's common to all normal distributions. 95% happen between 2 standard deviations of the mean, and then 99 here, I'll put it out here, 99.7% are within 3 standard deviations. So that's mu plus 3 sigma, mu minus 3 sigma. So that's how that's how they want you to answer these first few questions. So it says here, the graph below illustrates normal distribution for the prices paid for a particular model of HD television. So the mean price is 2,000 buckaroos. The standard deviation is $105. So it's asking us what is the approximate percentage of buyers who pay between $1,685 and $2,000. Well, in this case, 2,000 is the mean, right? Here, let's try to draw it on here. 2,000 is the mean, and 105 is the standard deviation. So this is going to be 2105 there. And then, yep, there it goes. My pen is going to decide that it's going to mess with me. And then here is going to be 105 less. So that's 1895, I think. Okay, we may have to do this show without this tool, unfortunately. Yep, it's not letting me. Here we go. So this one's going to be 1895 here. Anyway, doesn't look like it's going to work today. That stupid thing. All right. So 1685 ends up being $315 less than 2,000. So it's 3 standard deviations to the left of the mean. So basically what you got going is this half of the distribution is what they're talking about, from 3 standard deviations below up to the mean. So they want to know how much is there. So it's basically half of 99.7. So that's going to be, they want percent. So 49.85 is going to be half of 99.7. What's the approximate percentage of buyers who paid less than 1685? Well, if 50% lie less than the mean, and you got 49.85 between 1685 and the mean, that means you got 0.15% are going to be less than 1685. So between 2000 and 2210, well, that's going to be from the 2000 mark here. 2210 is going to be right here, 2 standards above the mean. Yeah, I don't know. So disappointing. So disappointing. Oh well, 2210 is 2 standard deviations above the mean. And then you just got to figure out what percentage is between the mean and 2 above. Well, that's going to be half of the 95%. So 47.5. And then between 2000 and 2105, well, that's between the mean and one above, so half of 68%. It's 34%. And then between 1895 and 2105, well, that is between one below and one above, so that's the 68%. And then percentage you paid more than 2210, well, there's going to be between the two tails out here, it's going to be 5% total, so 2.5% on each tail that's above 2 standards and below 2 standards. So that one's going to be 2.5%. So that's what they want you to do on these type of problems, is use that chart that I drew. Wendy's got a really good one on her videos. All righty. Estelle, unless you stop me, we're just going to charge forward, okay?
That sounds good.
All right, so I'm going to clear that. The graph illustrates the distribution of test scores taken by college algebra students. The maximum possible score on the test was 120, while the mean score was 76 and the standard deviation was 9. So they have all the values out there already. What percent of students were between 49 and 76? Well, remember we did that one before. You got 99.7% are going to be between 49 and 103. So half of 99.7% would be between 49 and 76. So that's going to be that 99.7 divided by 2 is 49.85. Percent of students who scored less than 58. Well, 58 represents 2 standards below the mean. So remember 2.5% on the left tail, 2.5% of the distribution goes to the right tail. So this is going to be 2.5%. What's the approximate percentage of students between 76 and 85? So 76 and 85. Remember, between 67 and 85 that's 68% in there. So between 76 and 85 is going to be 34%. And then what is the approximate percentage of students that score between 67 and 85? That's that 68% again. One below to one above, 68% of the data lies between those two numbers. All right. Okay, these ones are tricky. The first part's not bad. The arrows can only be dragged to z-scores that are accurate to one place after the decimal point. So round all z-squares to one decimal point if necessary. So sketch the region corresponding to the statement probability that z is less than -1.1. So that the number line here represents the z-scores. So we're definitely want to shade to the left of the value. And I'm going to click and drag this to -1.1. So that is going to be the answer for the first one. Let's submit it and doesn't want me to submit it. There we go. So it gave me credit for the first one, left of the value. Now I got to look at the second one. Sketch the region corresponding to the statement probability z is less than c equals 0.2. Okay, so I'm definitely going to go left of the value, but now I got to find that z-score, right? This is giving me the area. So where is the area 0.2? So we got to go to our calculator now, and when we're looking for a z-score on our calculator, we're going to use the inverse norm distribution. And the inverse norm, you'll see, is a pretty easy function to use on the calculator. So I'm going to open that up. Okay, so you look at your DISTR, we used those last couple weeks. Well, maybe not last week when we did uniform, but the week before we did binomial and Poisson, and we used that. That's where we're going for today. So we go second, distribution. Now I want to go to inverse norm. Hit enter, and it's going to ask you for some things. It asks you for the area. Well, I want an area of 0.2. So that's what I'm going to put there for area, 0.2. My mean is going to be 0 because it's the standard normal distribution as a mean of 0 and a standard deviation of 1. Then I hit paste, and it should tell me what my answer is. My z value is negative 0.8 if I go to the nearest 10th. So then I go up here, I'm definitely going to shade left of the value, and then I want to go to negative 0.8. Okay. Because it wanted nearest 1 decimal place on that one. So calculator again. Alrighty. So that's how you're going to run with ones like that one. They get a little bit tricky. I think we got one more of those coming. Yeah, number 4. Use the standard normal distribution, find the 2 z-scores that form the middle shaded region. Okay, the shaded region is symmetric about z equals 0 around your z-score, so 2 decimal places. Now your calculator actually, surprised. Actually, we're going to do the area we want here is 0.24. So we basically want 0.12 on each side of the 0. So I'm going to do 0.12 because then that's going to give me my, actually, let me look 1 minute at mode. Yeah, I'm on math print mode. The TI-84 plus CE does it different. Yeah, actually lets you put the tail in. If you got a left tail or a center tail or a right tail. We're working with kind of an old school. If you have this calculator, you're going to need to do it the way I'm doing it here. If you got the TI-84 plus CE calculator, you can actually choose the center. So that you do the total area and you can choose center on it, and it's going to give you both z values. But alas, we're working with this calculator. So what we're going to have to do is we're going to go inverse norm. I was actually doing it wrong. That's 0.12 is the area between the z-score and 0. So you actually want 0.5 minus 0.12 when we do this one. Let's see if my pen's going to work this time. So we want to do 0.5 minus 0.12. That's 0.38. So that's going to be this area out here is 0.38. And the 0.38 is going to correspond to this shaded region right here. So let's see, we're going to do 0.38. Mu is 0, standard deviation is 1, paste it. So my z value is going to be, want 2 decimal places, so negative 0.31. And luckily, the distribution symmetric, so this one's going to be positive 0.31. And lo and behold, that's what you got to do with the old TI-84 plus silver edition. They're a few years old. I wish I had the other calculator as well, but I do not. So there's number 4. 5, we did one like 5, so we don't need to do that one. Let's look at 6. It says sketch the region corresponding to the statement probability that z is between negative 0.1 and 0.7. So we want to shade between two values. We want to go from negative 0.1 to 0.7. So that's what we want right there. Then it wants you to find the probability that z is between those two values. So back to our calculator. Let's see if this one works different than the other one. This one, they're asking for a probability, so we don't want to use the inverse norm one. We want to use the norm CDF. So the cumulative distribution function. So hit that one. Good. It gives us a lower bound and an upper bound. If we want the tails, you want the lower tail, negative 1 E99 basically means negative 1 times 10 to the negative 99 power. So that's basically 0. And then the upper bound you'd put in, we're going to do an example like that. But for us right here, I'm going to put negative 0.1. And my upper bound is going to be 0.7. I'm still dealing with a mean of 0 and a standard deviation of 1. So then I paste that, and lo and behold, it's going to give me the answer. 0.2979 is what I'm looking at. All righty. So there it is. You got to click and drag it to the right value, and then, make the myopen mask smaller so we can see the calculator. Let's see, do we need to put this over here and put this over here? Oh, we don't want that. Okay. Because we don't necessarily need the keystrokes. All right, so here we go. On to number 7. The average student loan debt for college graduates is $25,900. Suppose that distribution is normal and the standard deviation is 12,300. What is the distribution of X? So you put the mean first, 25,900, and then the standard deviation, 12,300. Simple as that. Those are the way all of those work. Then it says find the probability that the college graduate has between 12,750 and 17,800 in student loan debt. So that's a calculator problem, right? We go to our calculator. We're going to go to that normal CDF distribution. So normal CDF. We got a lower of 12,750 and an upper of 17,800. My mean is going to be 25,900. And my standard deviation is 12,300. Then when I paste that, lo and behold, it's going to give us the answer. So that means that 11.26% of college graduates are going to have between those two debt numbers. Now, C becomes tricky. Wouldn't be tricky if we had the better calculator, but it's going to be tricky in this one. So the middle 10% of college graduates' loan debt lies between what two numbers? Oh, my pen is going to work for a minute. So middle 10%. So here's the mean right here. Middle 10% means you're going to have 5% right here and 5% right here. So with my old school calculator here, we got to find this Z value. So remember, between the mean and the left side is 50%. Between the mean and the right side is 50%. So the area in the tail out here is 45%. area in the tail is 45%. So that's what we're gonna do when we do the inverse mean. We're gonna do 45%. So let's see. Second distribution down to inverse norm, because I'm looking for the Z number. I'm not looking for the probability. So looking for the Z number. So 0.45 is my area. Mean was 25,900. Standard deviation was 12,300. And let's see what it is. So 24,354.37 is going to be the low number. 24,354.37 is it's not liking that. Nearest dollar. Perhaps the teacher should read the directions. Okay, so there's your nearest dollar. Now, one way you could do this one is you could subtract 25,900 minus that, and that's going to be the symmetry over to the right side of the mean. Or you could just go to your inverse norm again. You know how to put the last thing you put up there, you can edit that entry by hitting second enter, and then you can edit that entry. So instead of having 0.45, we'd have 0.55, because it's giving you the probability of things left. So we're going to change that to a 0.55, and then that's going to give you the above the mean answer. 27,446. All right. Well, like I said, if you all bought that calculator, here, let me show you what it looks like on that calculator. So area we wanted was 10%. The mean was 25,900. The standard deviation was 12,300. So that's what it's going to look like on that calculator. And then it's going to give you both answers when you bring it out to the screen. It gave you both answers. Okay. So that's 7. Let's see. I was going to do 8, 9, 10, and 12. They work very similarly, the other one. So let's see. Suppose that the duration of a particular type of criminal triangle is criminal trial, not criminal triangle, known to be normally distributed with a mean of 19 days. That's a long day. Standard deviation of 5 days. So there's our setup. If one of the trials is chosen at random, find the probability that it lasted at least 21 days. So this is where that E99 thing comes into play. So here's what I'm going to do. I'm going to go to second. Since they're asking for a probability, you're going to use normal CDF. So normal CDF. The lower is going to be, we want to last at least 21 days. So the lower is 21. The upper, I got to enter like infinity. So to enter infinity, you would do 1, and then the EE button's above the comma. So I go second EE 99. And that's basically 1 times 10 to the 99th power. So 1 and 99 zeros. Basically infinity. It's giving you the whole tail to the right of 21. Then the mean was 19. Standard deviation was 5. Let her rip. And we got 0.3446. If one of the trials is randomly chosen, find the probability that it lasted between 21 and 26 days. That one, you don't have to worry about the E99 stuff, because you go to second distribution, normal CDF. It even kept those on there for us. So that's all I would have to do is change the 1E99 to 26. And let it go to 0.2638. Then 63% of all these types of trials are completed within how many days? So they're asking you for the 63% less. So basically the tail to the left. So that one we don't have too much to worry about with our old school calculator. So we go second, distribution, inverse norm. I want the area to be 0.63. So now the Z number that it gives me, or the number of days it's going to give me, represents 63% of that's going to be less than that number. And that's what we want. So the mean is 19, standard deviation is 5. And we get 20 point, round to the nearest whole number. So 21 to the nearest whole number. All righty. So all of these ones for the rest of the assignment work this way, but let's tweak over a couple more. Oh, they got question. They have video question help too. That's kind of nice. All right, this one asks for quartiles, so it'd be useful to go over this one. So the amount of time that people spend at Grover Hot Springs is normally distributed with a mean of 67 minutes and a standard deviation of 15 minutes. So there's my distribution. Find the probability that a randomly selected person at the hot spring stays longer than 66 minutes. So go to distribution. I got normal CDF is asking for a probability, so normal CDF. If it asks for a data value, inverse norm. Okay, so normal CDF, the lower bound is at least 66 minutes. So 66 is the lower, 1E99 is the upper. My mean is 67. Standard deviation is 15. And it looks like I get 0.5266. Park Service is considering offering a discount for the 6% of their patrons who spend the least time at the hot springs. All right, what is the longest amount of time a patron can spend at the hot springs? So they're looking for that left-hand tail, right? They want 6% to be in that left-hand tail. So this time we're using the inverse norm because we're looking for a data value. So second distribution, inverse norm. And we have the area is 0.06. Mu is 67. Standard deviation is 15. And we get 43. What are we rounding to? 4 decimal places it says. So 43.6784. Okay, that's so everyone that spends that few minutes at the hot springs gets a discount. They want you in and out, I guess. All right, find the interquartile range. So Q1, remember 25% of the data happens to the left of Q1, right? That's where Q1 starts, quartile 1. All right, so we're going to go inverse norm again because we're looking for a data value. And we're only going to have to change the area. We want 25% to be left of the value because it's the first quartile. And it looks like we got 56.8827. And then we're going to do the same thing for Q3, but Q3 we're going to use 0.75. So we could actually go second entry and just go and change the 0.25 to a 0.75. And we got 77.1173. Then the IQR is going to be those two subtracted. So if I just hit minus now, it's going to allow me to take that prior answer and then subtract off 56.8827. Now it might not be rounded exactly the way we want it to. Let's see, but we can tweak it. 20.2346. Yeah, that should work. You subtract the two, and that's your interquartile range, the IQR. They're number 9. They're kind of fun, aren't they? Oh, the average THC content of marijuana. All right. Sold on the street is 9.5%. Suppose the THC content is normally distributed with a standard deviation of 2%. Okay, so we're going to go 9.5 with a standard deviation of 2. That's going to be our distribution. Find the probability that a randomly selected bag of marijuana sold on the street will have a THC content greater than 9. I guess the writers of this problem didn't live here in Eugene. So let's see. Second, distribution, normal CDF. We want to know if it's got greater than 9. So the lower is going to be 9. The upper is going to be that 1 second, comma, 99. Then my mean is 9.5 and my standard deviation is 2. We get 0.5987. Then it wants the 62nd percentile. Well, that's an inverse norm, right? Because they're looking for a data value. So here we go. Second distribution, inverse norm. We got an area of 0.63. Right, that was the number, wasn't it? 62, excuse me. Area 0.62. Because that 62 percentile means that 62% of the data is less than that. And that's what they're asking for. 9.5 is my mean. 2 is my standard deviation. Paste it up. I got 10.1110, it looks like, if I round it nearest 4. All righty, so there's number 10. Then number 11 works pretty much the same way as that. Number 12. Yeah, number 12 was the last one I was going to do because 13 and 14 are repeats too. Number 12 kind of is as well, but it's good to see it. Suppose that the weight of a seedless watermelon is normally distributed with a mean of 6 kilograms and has a standard deviation of 1.1. Oh, this one asks for median. Now, the whole deal with a normal distribution, half the data lies to the left of the mean, half the data lies to the right of the mean. Well, guess what the definition of median is? The place where half the data is less and half the data is more. So the median is the same as the mean. So that's going to be 6 as well. Find the z-score for a seedless watermelon weighing 7 kilograms. Okay, so that's the inverse norm, right? That's going to be the, what is the z-score? Oh, okay, no, that's not the formula for z-score. So z equals x minus mu over sigma is the formula for z-score. So that's what I have to calculate here. So the z number for 7 is going to be 7 minus 6. Make sure you put that in parentheses or just do it in your head. Divided by 1.1. So my z-score would be what do they want? Around nearest 4 decimals. So 0.9091 would be the z-score for that. What is the probability that a randomly selected watermelon will weigh more than 6.5 kilograms? So that one they're asking for a probability. So second distribution, normal CDF. My lower is going to be 6.5. My upper is going to be 1E99. And then we got a mean of 6 and a standard deviation of 1.1. So I got 0.3247. What is the probability that a randomly selected seedless watermelon will weigh between 6.5 and 7.2? So back to distribution, normal CDF. It's going to have retained those values, I hope. Perfect. Lower 6.5, upper 7.2, or we could have just edited out the 1E99. Down to paste. So 0.1871. Find the 75th percentile for the weight of the seedless watermelons. So that's asking you for a data value, it's asking you for the weight of a watermelon. So, and not the probability, so we go to inverse norm. Inverse norm, I got an area of 0.75. My mu value is 6. Standard deviation is 1.1. And we got 6.7419. All righty, so that is the chapter 6 homework in a nutshell. And there will, next week, remembers the midterm week. So I will open the class up as normal, but I won't be posting any Zoom video or anything next week. So if you choose to work on the test during regular class time next week, I'll be here, not necessarily to help because it's a test, but to answer clarifying questions or whatever. And the test is 3 hours. You have 3 hours to take it. And the suggested time they say it takes is about 100 minutes. So you're going to have like 80 extra minutes. All right. There is 7 or chapter 6. Let's look now and go to chapter 7. So chapter 7 talks all about the central limit theorem. Central limit theorem basically says that if you have a population and you take a bunch of, I don't know, bunch of samples, say they're all 50 from that population, all of these samples of 50 from the population, you calculated the means of all those samples, the means, if you collect enough of the population, so enough sample, what am I trying to say? You collect enough data from the sample, the average of the means ends up being normally distributed. All righty, so that's all the central limit theorem saying. There's a couple of formulas that we're going to go over. So let's go over number 1. Number 1 says the amount of pollutants that are found in waterways near large cities is normally distributed with a mean 9.8 parts per million and standard deviation 1.6. So I'm going to put 9.8 is my mean, standard deviation is 1.6. So there's that. And then we're talking about sample means. That's all that central limit theorem talks about is sample means. Turns out the mean of the sample means is still 9.8. And then the standard deviation, the formula we use. So here's the notation they use for standard deviation of the sample means. So they do sigma x bar is going to be sigma x divided by the square root of n. So 35 randomly selected large cities are studied. So n is 35 in this one. So what we want to enter in our calculator to calculate the standard deviation of x bar, we're going to enter 1.6 divided by square root of 35. And that's what's going to go in to the other space. So 1.6 divided by square root of 35. So 0.27, what do I want around? 4 decimal places, 0.2704. And then that distribution now behaves just like a normal distribution. So all the questions we answer about the distribution of x bar, we're going to use the same things on the calculator we used in the last section. So let's talk about the difference between part C and part D. Part C is talking about the whole population. So we're going to use the distribution in part A. Part D talks about the samples, so we're going to use the specs in part B. All righty. So what's the probability that one randomly selected city's waterway will have less than 10.8 parts per million pollutants? So they're asking for a probability. So that's the normal CDF. Less than 10.8. So the lower is going to be this -1 E99. Basically, that's -1 followed by 99 zeros. So that's like way to the left, right? The upper is going to be 10.8. The mean is going to be 9.8. And the standard deviation is going to be 1.6. So that probability is going to be 0.7340. And then it says same thing, but now just use the sample. What's the probability that the sample, the average number of pollutants less than 10.8? Okay, so then we go up here, second distribution again, normal CDF. It has the same thing, except now I'm going to switch that to my 0.2704 standard deviation because it's asking me about the sample and not the population. So 0.9999 is what I get for that, due to the fact that the standard deviation is so much less. For part D is the assumption that the distribution is normal necessary. Well, no, because they tell us it's normally distributed already. So let's see, did I get that one right? Yeah, it looks like so. We don't have to assume it's normally distributed because it tells us it's normally distributed already. Right there, it says normally distributed. So then no assumption needs to be made. Okay. Find the IQR for the average of the 35 cities. Okay, so we're using the 0.2704 one, and this one's asking me for the Q1 and Q3. So I'm going to need to use inverse norm. So my area is 0.25, 9.8 is my mean, 0.2704 is my standard deviation, and I get 9.6176. So that's telling us that 25% of the data is less than that. Okay, Q3, I'm just going to switch that 0.25 to a 0.75 for Q3. So we can do that. So I get 9.9824. And then for the last calculation, the IQR, you'd subtract those two. There, I just showed you the answer is 0.3648 if you subtract them. So there's number one, and these, all the questions work somewhat the same way as what we just did. But we should do one where the answer is yes, you have to assume the distribution is normal. So let's see. The average price of a college math textbook is 164. The standard deviation is 27. This one, they don't ask you for the normal distribution. First of all, it doesn't tell us that it's a normal distribution. So suppose that 15 textbooks are randomly chosen. So to find that, I'm going to have to do this, the standard deviation. I'm going to have to do 27 divided by square root of 15. So my standard deviation is going to be that 6.9714. For the group of 15, find the probability that the average price is between 158 and 168. So then we're going to go and do our distribution. We want to go normal CDF. We want to go 158 to 168. Then we want to put 164 in, and the standard deviation of 6.9714. Then I paste it. So 0.5222. Find the third quartile. So I want to do the inverse norm at the 0.75. So second distribution, inverse norm. I want to do the 0.75. I got a mu of 164. We got a standard deviation of 6.9714. And then it's going to tell me what my third quartile is, 168.70. Then is it necessary? Yes. You have to the number of data values in the sample is less than 30. If the number of picks was bigger than 30, then you don't have to say yes to that one. So we have to assume that the original distribution is normal in order to use what we just used. This is kind of tricky. All right. Marching right along. Let's do number 3. Suppose that the number of Facebook friends users have is normally distributed with a mean of 124 and a standard deviation of about 1 or at about 52. Assume 49 individuals are randomly chosen. Answer the following questions. So distribution of X bar is not going to be 124.52. It's going to be 124, 52 divided by square root of 49. Whoops. And we get 7.4286. Okay. Oh, look at this. I wonder if this changes. Oh, that one might be better calculator. I don't really want this thing over here on the right. Oh, hey, now we're getting somewhere with this doggone thing. All right, for the group of 49, find the probability that the average number of friends is less than 135. So same keystroke, second distribution. So find the probability number of friends is less than 35. We're gonna go down to normal CDF. Oh. I'm not liking this. We got to go back to the other one. All right, going back to the other one. All right. Normal CDF. Lower is less than 135. So lower is negative 1E99. Upper is 135. The mean is 124. Standard deviation 7.4286. Paste it. 0.9307. Wrong space. Okay, find the third quartile. Here we go, inverse norm. Inverse norm, area is 0.75. The mean is going to be the 124. Standard deviation 7.4286. And my third quartile then is the 129. We should be rounding to the whole number on that one because you're talking about people. But let's see. Yeah, it gave it to us. It wouldn't have given us 129 probably. Is the assumption that normal distribution is normal necessary? Well, let's see. I randomly selected 49 individuals. So no, I don't have to assume that. Because I did more than 49 or more than 30 in the sample. So it's going to automatically sort itself out as normal. The sample means. All right, there's number 3. Number 4, the amount of syrup, I pronounce it syrup, drives my wife crazy, she thinks it's syrup, but to each his own. The amount of syrup that people put on their pancakes is normally distributed with mean of 61 and a standard deviation of 9. So that one they are asking for the normal distribution. Suppose that 42 randomly selected people are observed pouring syrup on their pancakes. So to find out the standard deviation of the sample means, 61 divided by square root. No, it's going to be 9. What am I saying? 9 divided by square root of 42. 1.3887. Okay. If a single randomly selected individual is observed, find the probability that this person consumes between 63 and 64. So that's asking about the distribution of that capital X, right? That's asking about the first one. So second distribution, normal CDF. I got lower 63, upper 64.6. And then my mean is 61. My standard deviation is 9. And we get 0.0675. Now, for the group of 42 pancake eaters, find the probability of the average amount of syrups between those two values. So what we got to do is go back to distribution, normal CDF. It probably held on, good. It held on to all those because it's all I have to change then is the 1.3887. And we get 0.0701. Okay, do we have to assume the distribution is normal? No, because it tells us it's normal. So we don't have to assume that at all. Okay, so there's number 4. Okay, number 6. Number 5 is basically the same problem as number 4. All right, that's why we won't do that one. The lengths of adult males' hands are normally distributed with a mean of 185 and a standard deviation is 7. So it means 185, standard deviation 7. We got 47 randomly individuals are chosen. 47 individuals are randomly chosen. So 7 divided by square root of 47 is going to be my standard deviation. So 1.0211. And then it says, for the group of 47, find the probability that the average hand length is less than 183. So second distribution, normal CDF. Okay, lower is going to be the -1 E99 because we want less than 183. The upper will be 183. You got a mean of 185 and a standard deviation of 1.0211. I'm expecting a value to be that's less than 0.5, right? Because 183 is already less than the mean. So I'm expecting a value less than 0.5. Way less than 0.5. Because the standard deviation is so low. So 0.0251. Okay, find the first quartile. So that's an inverse. Second inverse norm. Area is 0.25. The mean was 185. Standard deviation is 1.0211. Paste it. So 184.3113. Is the assumption that the distribution is normal necessary? No, it tells us it's normal. So we don't have to assume it because it tells it. Alrighty, so there's that one. The last two talk about uniform distribution. All right. And sample means can still follow the normal distribution, even if the distribution comes from a uniform distribution. All right, so a computer selects a number X from 5 to 11 randomly and uniformly. So we got a uniform distribution, low value of 5, high value of 11. So suppose that the computer randomly picks 38 such numbers. What is the distribution of X bar for this selection of numbers? Okay, so now we have to compute the mean and the standard deviation of this uniform distribution. So we got to kind of go back to where we were a couple of, I guess it was last week we did uniform, but the mean of a uniform distribution was the low value plus the high value over 2. So the mean is going to be 8. So that's what we're assuming for that. The standard deviation, remember, of a normal distribution was that crazy formula. There's that square root of b minus a squared over n. So we would do square root of 11 minus 5. That's wrong. It was over 12. Over 12. That's going to be the standard deviation of my normal distribution. So here we go. I got square root, and we got 11 minus 5 squared over 12. Everything still stayed under the square root. So I got 1.7321. 1.7321. Now I got to divide that by the square root of 38, right? Because remember, sigma x bar equals sigma x divided by radical n So in my case, it's going to be 1.7321 divided by radical 38. Right, so then I'm doing that calculation next. So here we go. 1.7321 divided by radical 38. So 0.2810 pretty much. That's going to be my standard deviation. What is the probability that the average of 38 numbers will be more than 8.4? Now, let it be known we can use the normal distribution because we have more than 38 picks. All right. If it were less than 30, then we wouldn't be able to use the normal because the original distribution wasn't normal. All right. So here we go. I'm going to go second distribution. So the more than 8.4, so I'm going to go 8.4. And then 1E99. My mean was 8. And my standard deviation was 0.2810. Once again, this number should be less than 0.5 because you're in the right tail, right of the mean. So 0.0773 is what I come up with. All righty. And we'll do number 8. Then I hope that helps everybody get through their homework this week. I'm assuming you all have a lot of different versions and you're not seeing my exact assignment. I'm hoping. Let's see. Okay, yeah, it does change. Okay. Number of seconds X after the minute that class ends is uniformly distributed between 0 and 60. Suppose that 40 classes are clocked. What is the distribution for this group of classes? Well, the mean between 0 and 60 is 30. And then we got to calculate that standard deviation again, right? So I'm going to go square root of 60 minus 0 squared over 12. Now I'm going to end up taking that number and dividing by square root of 40, right? Then that's going to be divided by square root of 40. And that's the number that's going to go right in there. So let's see what we get. So square root 60 minus 0 is 60. I'm going to cut out the so-called middleman right there. So 60 squared over 12 equals that. And then I'm going to divide by square root of 40. And I get 2.7386. Now on the homework, you can press enter between each answer. I'm not so sure you're going to be able to do it on the test because if you didn't get part B wrong or correct, then you're not going to get part C correct either. So that's why it's nice to click enter, especially on the homework, to make sure you're correct. All right. Find the probability that the average of 40 classes will end with the second hand between 24 and 32 seconds. So I'm going to go second distribution, normal CDF, between 24 and 32. I got a mean of 30. And I got a standard deviation of 2.7386. And paste it. So I got that probability is pretty high, 0.7532. So even the one randomly selected class ending between 24 and 32 is going to be like 8 over 60, right? That's what we learned last time. But now if you pick 40 classes, find what is the probability that the average would be between 24 and 32. And that's a pretty high percentage. All right, everyone. So that's it. I'm going to stop sharing. Then I am going to stop recording. And there it is.